Hello, I'm Democritus, a Greek philosopher, and I lived around 5 BC. Myself and Leucippus were talking one day, and I noticed he looked sad. I said, "Hey, Leucippus, you look lost in thought, what's matter?" For I was always dropping my definite articles. He said, "That's exactly what I've been thinking about." He said, "Suppose I had some blue cheese, and I cut the cheese. Then I cut it again, and again, and again. Surely there must come a point at which it can't be divided any more." "Yes," I said, catching his drift, which was not a nice smell at all. "That would mean that matter is composed of indivisible building blocks." He said, "Let's call these particles atomos, meaning indivisible." I said, "It sounds quite catchy, and I'm sure future generations will use that word and no doubt shorten it to atom." Then he had my own ideas about atomos, that there must be different types and combinations of these particles which were responsible for the various forms of matter.
Hello, I'm John Dalton, and I was born in the Lake District. Today, I'm mostly remembered for my ideas of atoms and elements, which appeared in my 3 papers published in 1803. I propose that all atoms of a given element are identical, that atoms of different elements vary in mass and size, and finally, that atoms are indestructible.
Hello, I'm Professor J.J. Thomson. I was born in Manchester, and it's hard for me not to brag about the fact that I discovered the electron, the first known subatomic particle, in 1897. I was also the first to show that elements can have more than one stable isotope. And in 1906, I was awarded the Nobel Prize in Physics for my work on the conduction of electricity in gases. In trying to understand the nature of the atom, I had 3 genius ideas. My first idea of the atom was that each negatively charged electron was paired with a positively charged particle that followed it everywhere in the atom. My second idea was that perhaps the negatively charged electrons orbited a central region of positive charge. My third idea was that the negative electrons occupied a region of space that itself was of a uniform positive charge. I actually preferred the third idea, which became really popular, and everyone started to think of the atom as composed of a positive dough with electrons embedded within, and they called it the Thomson plum pudding model. Well, that was until my student Ernest Rutherford came along.
I'm Ernest Rutherford. Originally from New Zealand, I was a student of J.J. Thomson. I was not keen on his so-called plum pudding model, but I had no evidence to propose a new model. So, in 1909, I had Gaga and Marsden conduct an experiment in which they fired positively charged particles, alpha particles, at a thin sheet of gold. From the experiment I was able to conclude that an atom is composed of a positively charged nucleus, which contains most of the mass and yet occupies a small volume compared to the size of the atom. And orbiting the nucleus are the negatively charged electrons. Then, in 1917, I split the atom and discovered the proton, the source of the positive charge in the nucleus, for which I received the Nobel Prize for Physics in 1924.
Hello, I'm the Danish physicist Niels Bohr, Bohr by name but excited by nature, and in 1913 I became very excited when I proposed that in Rutherford's model of the atom the electrons move around the nucleus in fixed orbits, just like the planets. But more importantly, if they are given the right amount of energy, they can be excited to another orbital level. From this model, I was able to explain the visible spectrum of hydrogen. I was even more excited when I received the Nobel Prize for Physics in 1922.
So, both the electron and the proton had been discovered, but their masses couldn't account for the total mass of the atom. So, it was left to me to devise a cunning experiment in which, by 1932, I, James Chadwick, was able to discover the neutron, and I was awarded the Nobel Prize in 1935.
Thanks to the work of mainly British scientists, we now understand that an atom is typically 0.1 nanometers across, and composed of protons and neutrons in the nucleus, which itself is less than 1/10,000th of the size of the atom.